So folks, we've been talking about the periodic table in the last segment. In this segment, what we want to do is we want to actually make a connection between the Bohr model of the atom we talked about quite a bit earlier, and now the periodic table. So let's shift and now look at the Bohr model, again, a little bit more detail.
All right, guys, it turns out that when you look at atoms, they have shells of electrons. Now, we're going to take and draw a circle for the first shell, and the first shell has 2 electrons. You're going to see a pattern here. And after that, it's 8. So this atom has 8 electrons, and on the periodic table...
In its outer shell.
In its outer shell, a total of 10 electrons. So right now I have 10 electrons, and he's got an outer shell of 10. So let's say that I add and make 11 electrons, or
11 protons and
11 protons and 11 electrons. But now we've got 10, right? 2 in the middle, and then central one, 8 here. Where do we put the next one, Mr. Dmitrowicz?
It has to go to the next level.
Yeah, because it got a new level. And so that electron goes out here.
And this is what's really important that you understand. This outermost energy level, we call it the valence level, and it's the most important atom or level in the atom because this level is the one that interacts with other atoms.
Okay, yeah, because they can't touch. This is the part that touches, right? I can't touch your heart. All I can do is touch your skin, which we won't because we're trying to social distance. But you get the idea is that we're trying to, the only part that can touch is the part on the outside.
Right. So we only care about this guy, and this guy only has 1 electron in his outer shell. Is this atom happy the way it is?
No, and we're going to learn more about happy atoms.
So it's really important to understand the Bohr model because the periodic table, which we're going to look at right now, matches up pretty well with our view of the atom. So Mr. Bergmann, let's take a look at the periodic table again via video and see how that connects to the video we just watched.
And I encourage you guys, by the way, to get your periodic table out and you're going to mark on it. Actually write some things that we're going to tell you in this next clip.
So guys, what I want you to do now is take out your periodic table, your blank periodic table, and I want you to go at the top of column number 1, and I want you to write +1. And then column 2,
+2.
+2. Column 3,
Plus
+3. Skip column 14, actually. Column 15, that's a little tricky, -3. Mr. Dmitrowicz?
-2.
-2 for this column, and
-1.
1, and you can put a 0 up here if you want.
Why do they have 0 again?
Because they have no charge.
Yeah, they have no charge. They don't want to
They're
gain.
already happy.
Yeah. So the periodic table tells us a bunch of stuff, and today it's going to tell us about valence electrons. So if you're an atom, you want to be happy, right?
Yeah, I like happy.
Everyone wants to be happy.
Happy!
And if you want to be happy, you want to be stable.
Stable!
And in order to be stable, there's a magic number that every atom wants for Christmas to be stable.
They want 4.
That is incorrect. That is so correct. Are we allowed to hit each other with these? Back in the olden days, we were able to do it.
8, actually, folks. They want to have 8 electrons. The magic number is, what is it?
8.
It's what?
And it's actually called an octet. So we're going to call it an octet. So every single atom, when they're born, is they want to have 8. Let's say you have 7. Are you happy?
No.
He's very unhappy. I'll console him later. But since he only has 7, he wants to do everything he can to get.
I need to get 8.
8. Now, how do we know how many electrons are in each atom on the periodic table?
Well, it's actually on the table itself. So, like, the happiest guys on the planet are the ones who already have 8. That's these cats over here.
So let's just do this really quickly. If you look at these groups, group 1,
Group 1,
group 2,
group
we're skipping this whole middle block.
Group 13, which is, do you see the 3 at the end of 13?
So that's 3, 4, 5, 6, 7, 8. We kind of ignore helium at the very top there. But see those magic group numbers there? That's the number of electrons they have.
8, so we're going to ignore the guys in the middle for right now.
Yep.
And so they want to get 8. So let's think about this, Mr. Dmitrowicz. So what if I've only got like 1 electron? I mean, if I really want 8, is it, can I get 7?
So you're a sad panda if you only have 1, right? You're very sad because the idea of gaining 7, it's going to be really hard to have 7 things that want to give.
So that would be like from group number 1. So if I'm like potassium and I want to have 8, to gain 7, pretty tough. So what do we do?
So here's the thing. You can also lose electrons that have a full outer shell. Now
Remember an electron. Oh yeah.
So remember the video that we looked at just prior here?
Yeah.
Every atom has energy levels or shells. So if an inner shell is full with
That's
8, with 8,
well, I
and
lose
I have
one, I have 8.
And I have just 1 sitting in the outer shell. If we were to get rid of that, that means that my inner shell now has 8. So that means that these atoms over here
Lose electrons.
The ones that have 1, 2, and 3, it's easier for them to lose electrons than to try and gain electrons.
So if there's up to like 8, right? So if you're like 1, 2, or 3, it's easy to lose them. If you're like 7 or 6, 5, 6, 7, or 8, it's easier to gain them.
Gain electrons, which is, he mentioned this before. This group over here, we call them the noble gases. They have 8 electrons. Do they want to bond with other things?
No, they're boring chemicals.
They really are boring. We call them noble because they don't want to interact. On this side, by the way, it does matter when you lose electrons. So if I give you electrons which are negatively charged, what's going to happen to you?
You feel negative.
You're going to feel negative, and you're going to be negatively charged.
Negative charge.
What's going to happen to me if I lose electrons to you? What's going to happen to me?
Positive charge.
I become positive charge. So what's really cool about this is we have a kind of a code here on the board. If I'm in group 1 and I lose 1 electron, now I have 1 less negative, so I'm going to be plus 1.
Yep.
How about group 2?
Positive 2. Because you're going to lose 2 electrons, gain 2, positive 2 charge.
Wait for the magic here. Skipping the middle block, group 13.
Plus 3 is
Plus-
their charge, lose 3 electrons. That's kind of weird. You're losing to gain the charge, right?
Now let's jump over here to number 4 is
This is
tough.
a tricky one.
We're gonna ignore 4s right now because
Yeah.
they don't know
They
what
do
they're
weird
doing.
stuff.
But let's go to 5. If you have 5, how many electrons do you want to gain?
3, but now I'm gaining. So gain 3, I get a negative charge because I'm gaining a negative thing, an electron.
So that means that everything in this group is going to have
-3.
-3 charge.
Negative 2, gain
Negative
2 negative electrons, and this last group, it's second to last group I should say, gains 1 electron,
Which is negative.
which is 1 negative, and their charge is 1 negative.
This is important because now when we're going to work about putting the positive and negatives together, we need to know what the charges are, and the periodic table helps us with that pretty greatly, correct?
Yeah.
All right, see you.
So, Mr. Dmitrowicz, we gotta be happy, right?
We do. So just like us wanting to be happy, we've kind of anthropomorphized given atoms human characteristics, but we want them to be happy. In order to be happy, they want to be what, Mr. Bergmann again?
8 octet.
Yeah, you can even jump straight to that because yeah, they want to be stable, but how do they become stable? They always want to have 8 electrons in our cell. So lock that in because that's going to determine how we do bonding and how we put everything together, which is going to be in the next video. But have your periodic table that's marked up for everything we're doing from here on out. Anything to add to that, Mr. Bergmann?
Yeah, that's awesome. So, hey guys, we'll see you guys in class because you guys are awesome.